Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem based on the concepts of increasing and decreasing functions. So as per the problem, for each of the following graphs, state the intervals where the function is increasing, the intervals where the function is decreasing, and the points where the tangent to the function is horizontal. So let's start with the first graph. So we'll answer the first question. So the intervals where the function is increasing. Now function is increasing in the interval if the slope of the tangent in that interval, the slope of the tangent to the curve or the graph is positive. So that means if we draw a tangent to that curve in that interval, it should slope upwards from left to right. So as you can see in this graph, this arm of this curve is sloping upwards from left to right, because if we draw any tangent to this arm of this curve, it will have a positive slope. So therefore, this function is increasing for all x values to the left side of this point -1. So one interval for which this function is increasing is x is less than -1. Now in interval notation, we can write this interval as -infinity to -1. And we'll use the rounded brackets because the endpoints are not included. Now another interval in which this function is increasing is from this point 2 onwards to the right side. So as you can see, any tangent we draw to this part of the curve will have a positive slope because it's sloping upward from left to right. So therefore, the other interval is x is greater than 2. And in interval notation, we can write it as 2 to infinity. Now we can answer the second question. So we have to find the interval where the function is decreasing. And that's the interval in which if we draw a tangent to the curve, it will have a negative slope, or it would slope downwards from left to right. So that will be the part of the curve between x equals -1 and x equals 2. So all of these tangents drawn to this curve have negative slope. So the interval will be, so x is greater than -1 and less than 2. And in the interval notation, we'll write it as -1 to 2. Now we can find the points where the tangent to the function is horizontal, and those are the peaks and the valleys in the graph. So this graph has a peak at -1. So that's the first point at which the tangent is horizontal. And the other point is the valley formed by this graph at 2, -1. So these are the 2 points at which the tangent is horizontal. So now we can analyze the second graph. So we'll answer the first question, the intervals where the function is increasing. So that means we have to identify the interval in which the tangent to the curve has a positive slope. And that's the arm from this x equals -1 to x equals 1. So the interval in the inequality notation is x is greater than -1 and less than 1. And in the interval notation, we can write it as -1, 1. Now, so this is the only interval in which the function is increasing. So now we can answer the second question. So the interval where the function is decreasing, and that's the part or the interval in which the slope of the tangent to the curve is negative. So that will be the part to the left side of 2 x equals -1, and then the part to the right side of x equals 1. So the first interval on the left side will be x is less than -1, and in the interval notation we can write it as -infinity to -1, and the other interval will be x is greater than 1, and in interval notation it will be 1 to positive infinity. So these are the two intervals in which the function is decreasing. Now the third question, so points where the tangent to the function is horizontal. Now in this case there is a valley being formed at -1, 2. So that's the first point at which the tangent is horizontal, and the other point is the peak point, which is 1, 4. So these are the two only points that have the tangent as a horizontal tangent. So now we can analyze the third graph. So we have to identify the interval where the function is increasing. So we have to identify the part of the curve where the tangent to the curve has a positive slope. So that's the part of the curve to the left side of x equals -2, because this curve has tangent that have positive slope. So this should be x is less than -2. So the interval is written for x values, and in the interval notation it will be -infinity to -2. So this is the only interval in which the function is increasing. Now the interval for which the function is decreasing, and that's the part of the curve between -2 and 2, because all tangents to this part of the curve have a negative slope. So the first interval will be x is between -2 and 2, and in interval notation it will be written as -2, 2. And the other interval is the curve to the right side of 2. So this one also has tangents that have negative slope. So the other interval will be x is greater than 2. And in interval notation that can be written as 2 to positive infinity. So these are the only two intervals on which the function is decreasing. Now we can answer the third question. So the point where the tangent to the function is horizontal, in this case the graph is not forming any peaks or valleys. So that's why there are no points at which the tangent to the function is horizontal. So now we can analyze the last graph. So we'll start with the interval where the function is increasing. So the part of the curve where the tangent to the function is horizontal is between x equals -1 and x equals 2, because in this part all tangents drawn to this curve will have a positive slope. So the first interval is x is greater than -1 and less than 2. In the interval notation, this can be written as -1 to 2. Now the other interval in which this function is increasing is to the right side of 3, because to the right side any tangent that we draw to this function will have a positive slope. So the other interval is x is greater than 3. And in the interval notation, it is 3 to positive infinity. Now we can identify the interval in which the function is decreasing, and that's the part where this tangent to the function has negative slope. So the first part is the curve to the left side of -1. So the interval is x is less than -1, and in interval notation it will be -infinity to -1. And there's another interval on which the function is decreasing, and that's from 2 to 3. So any tangent we draw here has negative slope. So the other interval is, so x is greater than 2 but less than 3. So the interval can be written in interval notation as 2, 3. Now we can identify the points at which the tangent is horizontal to the function. Now in this graph, there is one peak point at x equals 2, and that point is 2, 3. Now the other two turning points, so I'll highlight it. So the two red points are cusp points. So these are not points that form a curvy peak or valley. In this case, it's valley. So these are sudden turning points. So that's why these are called cusps. And at these points, the derivative is undefined. So as a result, we cannot draw a tangent to this function at these points. So therefore, these points are not the points where the tangent is horizontal. So there's a very important concept we need to understand and memorize, that at cusp points, which are sudden turning points, the tangent to the function is not horizontal. So in this case, there is only one point at which the tangent is horizontal. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to understand the given graph and then identify its key characteristics in terms of interval for increase, interval for decrease, and points where the tangent is horizontal. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.